is Donna. I'm one of the DSC leads at UNSW, and thanks so much for taking the time out to come to our Introduction to Kubernetes event. This event is happening on Zoom, as you can see, so please keep your microphones on mute unless you're speaking. And just so you know, we are recording this session, so if you do not want to be recorded, please do not speak on the microphone. I'm really excited for this event because I've wanted to know about Kubernetes for a really long time. So I'll pass it over to Zachariah, who is the DSC lead at the University of Melbourne.
Thank you, Donna. Hi, everyone. My name is Zachariah, and I am the DSC lead at the University of Melbourne. I'm super excited and honored to be co-hosting this event alongside DSC UNSW and Daniel King. I would like to welcome you all on behalf of the DSC team at UniMelb, and thank you for sparing the time to be with us here today. I hope you are all excited as we are going to be learning about a new and fun topic. You might be wondering, what is Kubernetes? Why is it used? When is it used? Can you show me a quick example of how a beginner could utilize it? Well, I cannot answer these questions for you, but our guest speaker, Daniel, is going to answer all of these for you today. Daniel is a cloud architect, and most days he's training people on cloud tech. He has taken time out of his busy schedule to be with us here today. We are super honored to hear from him. These are just some of the many amazing skills he has, and I'm super excited to hear from him today. With that said, I'll be passing it on to Daniel.
Great, thank you very much. Thank you very much. So I had a couple of comments there around the background. Yes, that is actually the Google search. It's close to real time, but I've isolated that to the ANZ region. So you can actually see who is, what everyone's searching for. It's the trends for Google search. Now, I am going to share my screen. Please, it is Friday afternoon. I spend my Monday to Fridays typically training up customers for Google, training up Google's partners, and training up Google staff as well. So I spend my life in slides and demos. I'm going to suggest for this session, I'm not going to use any slides. So hopefully you guys are okay with that. But what I do need though is some interaction, right? So this is the plan for today. We are going to start off fairly gentle. It is going to be a gentle introduction to Kubernetes, okay? I will take you through from scratch. I have not pre-prepared anything in this environment. The idea is I'm going to document everything I've done for you and make that available for everyone on the call or anyone who's watching the recording. So you should be able to follow along. So right from signing up for Google Cloud to being able to do multiple scale out events on a Kubernetes cluster. Okay, we got 60 minutes. This is going to be a challenge, but I want to make sure that you guys are understanding what we're going through. So please, let me just get up the chat. I want to make sure, let's find the chat again. Make sure everyone has an opportunity to ask questions. More chat. Here we go. Okay, I got the chat up and ready. So can everyone see the screen okay? Everyone's good? Thumbs up?
Yeah.
Perfect. So we're going to start with, I'm going to take you to, firstly, just let me know in the chat if you are a developer. I'm kind of hoping most people here should be, right? Because that is the way that, that I've actually architected this particular demo. Normally, I'm talking to enterprise administration staff, so IT ops people. Their coding skills is improving, but they are not software engineers by any means. So today's demo, it's going to be a little bit more command line orientated than I would normally demo. But let's see how we go. First thing you need to do is Google Cloud, not the certifications. The very first landing page here, cloud.google.com. we're going to get started for free. That's one of the good things that Google has. Google has $300 US, right? That's great for us Aussies. 450, 460 Aussie dollars worth of resources that we can use in Google Cloud for free. I'll tell you a little tip. It is based on the Google account. So for every Google account that you have, that is $300 US. So we're going to create an account right now. I'm going to create an account for myself. Let's call this Daniel King. My email address, I'm going to use an email for, let's call it DSC demo. Okay, let's give it a password. This is going to be super quick. I'm not going to talk you through these steps. We're just going to do what's needed to get access to Google Cloud. And apparently I cannot type my password on Friday. Let's make it demo 2, 23. Are you serious? 99. Here we go. I'm not going to fill in that. Yes, I am going to put in my, it's going to be somewhere here. And yes. Last step. We are almost done. We do need to agree to the terms. Yes, I agree. Of course we do. And one little snag, one little catch is you do need a credit card. Okay. In order to use Google Cloud, Google needs to make sure that when you're using their resources, that they do have the ability to charge you. So here you go, $300 US. $300 US you need to use within the first 90 days. So I will put my home address just for everyone who doesn't know me. I am based in Brisbane. So it is quite warm up here today. When we are finishing this session, I'll be jumping in the pool for sure. Let me just switch to a different screen while I fill in this one. 20. And start my free trial. Welcome. Doesn't get any easier. Welcome to Google Cloud. So hopefully everyone has had an opportunity to at least play around with a little bit of Google Cloud. If you haven't, you absolutely should. Okay. We're going to create a new project. Let's call it DSC API Kubernetes. So when you're creating a project, projects are where you're going to place all your resources for Google Cloud. So it is also where the billing gets attached. So the most important thing for us is going to be this project ID that we get. We create a new project. Okay, please tell me how many times can you use the same credit card? That is a good question. I have not hit that limit. I do lots of demos for the last 3.5 years. And as long as your credit card is known to Google, then they don't charge it, okay? If it is an unknown credit card, the very first time, they will put a small charge on there. Usually it's under 20 cents, just to verify that they can make charges against that. So let's go back to my steps. Signing up to Google Cloud via the Google Cloud Console. Let's check this one off. I think we've achieved that. Okay. I need to set up a development environment. Yeah, I do have a nice big development machine here. I've also got a development laptop, but I have my Visual Studio Code. I've got all my different linters. I've got all my plugins. That's going to be hard for you to replicate. So I'm not going to try. We're going to set one up from scratch, and it takes seconds inside the Cloud Console because Google provides us this little feature here called the Cloud Shell. So I'm just clicking on the Cloud Shell. What you'll see, it's going to open up a terminal down the bottom. In fact, I'm going to make that full screen so everyone can see it. So what's happening in the background is a virtual machine is being provisioned right now. Google gives that to me for free. You get one virtual machine that essentially gets created every time we come into the Cloud Shell. I also get 5 gig of data that follows around my account. So this brand new account that we just created. So here we go. We now have, let me make it bigger, a terminal in order for us to be able to run our code. Who here loves Vi? Does anyone actually love Vi? Is that still a thing? I'm not sure that is a thing. I'm going to cheat. Up here in the top corner, there is a built-in editor. Okay, it's not quite as good as VS Code. I must admit, I do like VS Code a little bit better, but for the demo, I think this particular built-in editor is going to do nicely. Hey, I got a development environment and Google's given that to me for free. I'm going to check that off. Here we go. We have set up our development environment. Let's create a simple API and just make sure that we have an API that we can later on deploy to our Kubernetes cluster. Move that one over to the side. I had a choice of a lot of languages to do. I generally find I can't get a consensus in a room full of developers as to which language should be the best one to demo with. So I'm going to take my choice and I'm going to choose something relatively straightforward. A language that's usually used for full stack development. I'm going to use JavaScript and Node. Stavia, yeah. Mickey, Erlang, yeah, I don't know. Chris, Rust. I've heard good things about Rust, but I'm going to stick with Node.js. So anyone here a Node.js developer or has had some time in Node.js? Because what we're going to do is very, very simple. Okay, Stavia is saying yes. Can everyone see? Yes, you can see the Cloud Shell. Don't wait. Over the bottom. So I'm going to work down here at the moment. So first thing you do, let's create a directory. Let's call it our API demo directory. Oh, look at that. In my editor, I've now got a directory. Fantastic. Let's CD into that directory. And I'll make this a little bit bigger just for the moment. Let's do an npm init. If you're a Node developer, this is just how you start your projects. I'm going to take all the defaults. I'll put in a description, Dan's demo for DSC, Kubernetes. Next, all the way through. Right, we now have the basics. We have a package.json. In fact, what I'm going to do, I'm going to copy across our checklist here. I'm going to copy this into our code. I'm going to create a new file. It's going to be our to-do.txt. And in here, I'm going to check these off as we go. That way I don't have to change. Let me get rid of that file. Okay, here we are. We're in our project. We're in the process of creating a simple API. One of the simplest things to demo for Kubernetes, let's create a website. Just a very simple API-oriented website. I'm going to cheat. And I'm going to say Node Express.js, hello world. So this is straight from the Express.js website. So everyone should be able to find this relatively easy. It doesn't get any simpler than this. And I'm going to explain this code to you in a second. Let's go back to my editor. I'm going to create a file for my app called index.json. I'm going to paste in that code. Oh, let's make that a little bit bigger for you. I think that could be improved. Let's go font size. Editor, let's make that 30. There we go. That's a bit better. All right, what we're doing, let's bring in a Node web server. We've got a port to start it on. Look, I'm going to change the port just for simplicity. I usually run on port 8080. So I'm going to change that to 8080. And I'm also going to add something. I'm going to pull the port from an environment variable. Stavia, you can absolutely use 3000. My preference is to use 8080. because there is one particular service in Google Cloud which defaults to 8080. So if I use 8080, then I know my application will actually deploy across all of Google Cloud's infrastructure. No, not Firebase. My favorite service is actually Google Cloud Run. So maybe that'll be a follow-on. Let's work that out. Let's create an API. What's our API going to be about? It's Friday. I'm thinking about what I'm going to be doing tomorrow. I'm heading off to Bunnings. Usually when I'm heading to Bunnings, I'm generally looking for a Sanger, right? So a snag Sanger. So let's create a where's my snag Sanger API? Because I want to know that the Bunnings I'm going to has a barbecue and they have Sangers available. Otherwise, I'm not going there, right? So we have our Sanger, and we're just going to say our app is listening. It's not going to be listening there all the time, so I'm going to remove that. How are we traveling? Okay, I think we're good. So there's not too much of this. We're starting up the web server. I have a defined a port. I'm either going to pull the port variable from the environment or port 8080. A request just to the root. It's going to respond with, where's my snag Sanger API? Let's execute this. Before we execute, let's put in a little startup script here that says, let's call it start and node index.js. That's it. I should now have a website that I can execute. Let's go to our shell. First thing, we're in the right folder. Let's install what we need, which is Express. Here we go, my Express is there. I should now be able to start my server and just prove to you that this is all working. So npm, I can just run start. My app is listening. Okay, it should be listening on port 8080. But hang on, this isn't my local development environment. So how can I actually connect to port 8080? Well, Google Cloud Editor helps me out. I can preview, and I can change the port number, but I can preview just like I'm doing a local host request. Here we go. Where's my snag Sanger API? Okay, we got our API running. It's as though it's running on my laptop, even though we're using Google Cloud to provide that for us. We are here to talk about Kubernetes. Okay. Before we can talk about Kubernetes, we need to know about Docker, right? So we're going to create a file. It's going to be called a Docker file. Now, I am not going to run a class on Docker. I can speak to you for quite a while on Docker. All you need to know is it requires a Docker file. Docker is it's an isolation technology. It's at the operating system level. So it is able to bundle up my application and the dependencies and provide an OS isolation deployable unit that we call a container. Okay, the container is the runtime version of the image, and we build the image. How do we build the image? It looks exactly like this. So I'm going to say, you know what? I like to run Node version 12, even though, get this, the environment I'm doing my development in, let's make it a little bit bigger. The environment I just ran this hello world in, this where's my snag Sanger, was actually in version 10. One of the nice attributes of running your application in a container is I can have multiple runtimes of all different versions, all running on the same machine because they're all isolated from each other. Stabby's got a question. How different is it from Python virtual environments? I can't answer that question for you, Stabby. I just don't have enough experience on the Python side, but let me just say the building blocks of Docker are extremely well adopted across the whole industry. right? So obviously I'm here advocating for Google Cloud, but Docker will work on your laptop, Azure, AWS, GCP. It doesn't matter. It's agnostic to where it's running. As long as you have something called the Docker runtime, which I do happen to have running in this environment, we should be good to go. Developers love it because developers get to decide exactly how all their dependencies for application get run and pulled together. Then they can hand this Docker file to a deployment team and we know it's going to work. So let's get started. We now have our Docker file. Next thing, a Docker file. We need to create this image, right? Our application, our source code in a built environment with all the dependencies. Docker makes that easy. Docker build, let's call it API demo. So I'm just giving it a tag. So this is a name and the full stop, that's important. That's referring to the location for the Docker file. And clearly I'm not in the right location. I'm not in the right directory. Here we go. Here we go. Let's run that file again. So those 6 steps we had here, they are now getting run in the background. So step 2, step 3 of 6, step 4 of 6. So it's copying node, right? So that's the operating system that's going to be running my application, right? It's creating a working directory inside the container. It's copying across my package.json. If you're a Node developer, you know that that defines your whole application. I am going to install all my dependencies from my app, copy those dependencies and everything for the app into the container, and then run the app. Pretty simple. If we have a look now, if I go Docker images, I have this image called API demo in my development environment. Okay. What do I do with it? Well, let's just make sure. Here's my app running in the background. It's running in this other tab. I'm going to cancel this tab. There you go. Make it a bit bigger. So if I go back to my app, it's not running. Let's have a look how easy it is to run our Docker image. And I'm using these words intentionally, right? So Docker run. So we're going to run it. I am going to detach it so it runs in the background. But I'm going to say port 8080 in my development environment matches port 8080 inside the container. And the image I'm going to use is API demo. Watch this magic happen. Okay, I see a big long number. Don't really know what it means. Let me just try my app. Oh, okay. My app's now running. It's running in the background. I can see that process running. So Docker PS. So I can see there is a container running. It is using the image of API demo. And that's the command that it executed. And it only started 22 seconds ago. That's all right. The benefit here being that I now have a completely isolated environment. I could spin up 10 of these and they could all be different node versions if I wanted to. I don't know why I wouldn't want to, but you can do that. And they do not talk to each other at all, but we can access them externally. Okay. Stabby's got a question. Why are there 2 images for Docker if we just made one? Yep, good question. So inside my Docker file, the very first line here was from node 12-slim. That itself is also an image. So that's the image. If I go back to Docker, whoops, better not do that. If I go back down here, if I go Docker images, it is the node 12.slim that we pulled down. So images can refer to images. That node 12.slim, I didn't create that. So where did this come from? That's kind of weird. You need a repository for images, right? In this case, I'm pulling it from a public repository. I didn't specify the path. There you go. Christopher's got it, right? Docker Hub. So we're going to go to Docker Hub. Docker Hub is this wonderful world of pre-made images. You just saw me make my sausage Sanger API I created this image. If I wanted to, I could sign up and publish it in Docker Hub, so then others could pull down that same image. You probably wouldn't want to, but let me give an example. WordPress. There are 8,115 images of WordPress built by all different people. So if in my application, I went back here and I said, you know what, and I changed that to WordPress, I would actually pull down WordPress from that public registry. If I go and have a look, there's only one that is called just WordPress, and that is from the vendor itself. Okay, makes things very quick to pull in very large dependencies. So Yuval's asking, what exactly is a Docker image again? So a Docker image is everything here. That is what makes the Docker image. Okay, so it is my dependency of the node. Okay, it is my application folder. It's all the application requirements. Okay, everything we need to bundle up my app. Okay, I'm gonna keep moving. I'll come back to some of these questions. So now we have our app, and it's running in. Let me get back and find my shell. I'm going to kill off this container. Actually, I need the ID. That's the ID of the container. And I'm going to kill that container just to verify. If I go back and refresh, it is no longer running. That's okay. What if I'm working with Donna, right? So Donna's a dev as well. I need to share my image with Donna, but it's in my development environment. That's not good. Really what I want to do is store it somewhere centrally, like a registry, like Docker Hub. Docker Hub's public though. So I don't want to store it there. You know, I'm just playing around here. It's not production ready. So let's work out, where could we store our image? There is a service. So this web interface, by the way, this is called the Google Cloud Console. We're going to store our image, if we go all the way down, into this one here, Artifact Registry. We need this. In fact, the whole reason we're talking about Docker at the moment is because Kubernetes, where we're going to, Kubernetes is just an orchestration engine, right? It just helps us automate and manage our containers. So we need containers, we need an artifact registry, we needed that, all of that in place before we can even get started with Kubernetes. So artifact registry, I like the idea of this. This is a private repository. I could set up permission. So just Donna and I, we're the only two going to be in here. Oh, I got to turn it on. That's kind of weird. But now that you think of it, it's actually pretty cool. My project, API Kubernetes, that's the name of the project. APIs need to be turned on project by project. All right, so if you're a solo developer, it doesn't really matter. If you are an enterprise developer, then all of a sudden your organization may decide which APIs you can turn on and which ones you cannot, right? So there is a governance layer there. So we had to turn on our artifact registry. Here it is. Very first thing, very simply, we need to create a repository. And this repository, if you've ever worked with any artifact management registries, yeah, I could store my NPMs in there. I could put my apps in there, Mavens, including Docker. So we're going to choose Docker. I'm just going to take all the defaults. Actually, I'm going to store it in Sydney. There you go. I'm going to put it in Sydney. I'm going to create this secure encrypted registry where I can now store my API demo registry, where I can now store my image. So then I can share it with all my other devs. Should be ready in 5, 4, 3, 2, 1. Stavia, yes. What is Kubernetes exactly? You are going to find out very soon. In the next 30 minutes, I expect you will be an advocate for Kubernetes. We now have our container registry, a central location. This is so I can share it with Donna. Let's have a look. We're going to copy this path. That is the path that I need to store my image. So then what I do is I go back to my Cloud Shell. I go Docker images. My image is here. It's called API demo, but it's on my machine. What if I did this? If I build that image again, I'm going to use exactly the same command I did before, which was this, except now I'm going to preface it with that path of the registry. Oops, that's not it. Let me preface it with the path of the registry, which was that one there. Let me paste that in. That's the only change I'm going to make. So now my Docker file is being looked at again. This file here, it is being built. Okay, it is now being built with a different name. So you'll see here, if I go Docker images, I'll change the resolution so it formats nicely. There you go. API demo is the first one. Here is the new name. In fact, it's the identical image because look, the identifier is identical. Docker was smart enough to know, okay, I don't need to rebuild it. Dan's just changed the name. In fact, that one that I just created, it says it was created 9 minutes ago. The benefit is I can now do this. Just like a Git commit. You know, when you do your commits and then you push up your changes, I'm going to do a Docker push and I'm going to push that image. That image now is being taken out of my environment, but it's being put into the central repository. Oh, I got a access denied here. Location. Did I choose the right path? Docker push. 147 meg. Yes, that is a combination of the application along with all the dependencies. API demo registry. That is certainly, I missed a step. Docker cannot push to a registry that it does not have permissions to. So what led me to that was, look at this, permission denied. So Docker, we don't know who Docker is actually authenticating as. So there was a step here that I missed, which was set up instructions. I'm going to copy that, paste it in. And now I'm going to push that up and we should be good. All 147 meg, as Yuval said, is being pushed up to that central location. And if I go back, give it a second. How does Docker know which image to push to the cloud? Yeah, because I just specified that on the command line. So this one here, Docker push, this Australia Southeast 1.docker.package.dev/API Kubernetes/API demo registry/API demo is the name of the image. And I know that because if I go Docker images, we renamed it earlier. So Docker just looks at that name and is able to push that up. Let's go to our registry. I'm going to do a refresh here. And we have, fingers crossed. Hey, we now have our image located in a central location hosted in Google Cloud Artifact Registry, securely encrypted. It's just been pushed up right now. How is that useful? Well, it's useful because I'm now going to remove my local images. Just so you know, this isn't any smoke and mirrors. To remove an image, I do this. I remove this one. That's the one we're concerned about. I'm going to paste that. It has now been removed from my machine. So if I go Docker images, it is no longer here. Let's pretend I wish to now run this exact container, but now I am, maybe this is now Donna, right? So Donna comes over here and Donna looks at the registry and goes, oh, okay, this is the one I want, copies this image name, goes in here and says, I want to run that. It's not on my machine. I didn't build it. And that is not pasting. Let's come back, copy, paste. unable to find image locally. Okay, that's a good thing because I didn't have it locally. It then pulled down the image from the private registry. And if I have a look at my machine, it is now here. Right, so we built an image. I'm gonna go back to my checklist here. Let's go back. There's my code. Let me remove that one. Look at our to-dos. We've certainly created our simple API. We knew that was working. We built a Docker image locally and we deployed that and we showed you that running in the web page. So we know that was working. We then pushed it into a central location. That was the artifact registry. We're good to go. We can now share our images, share our application. You know, we know it's going to work because the application and all the dependencies are all bundled together. Right, so you're not going to have a situation where, oh, I'm running a different node version. Now I've got troubles. I need to remove my version, put in a new version. No, it's all in that container. So next thing we need to do, we were building using Cloud Shell. So, I wouldn't imagine students have really expensive, powerful laptops. And if you're doing a lot of build processes, maybe you just got, a borrowed laptop from someone and it doesn't have a lot of grunt, a lot of power. Could we get Google Cloud to build that Docker image for us? And then get Google Cloud to build that image and store it in the container registry, and it doesn't use any of my compute. That'd be pretty cool. Let's see what that looks like. If I have a look in my Cloud Shell, let's make this a little bit bigger for you. Very simply, almost exactly the same. Actually, let me get what's my image name? Here we go. My image name is this. We're now going to use a service called Google Cloud Build. It's just a build service. It accepts requests to build. And I'm going to say, oops, API, Kubernetes. I didn't copy it all, did I? History, let me get my image name. Here we go, this one. Gcloud, builds, submit. So watch what happens now. My source code and my Docker file, they're going to get uploaded to Google. My machine is no longer going to build that Docker image. We're handing it to Google. They're going to use a service called Google Cloud Build. It's going to build it. There you go. They're looking at it. They're going to start building it. We're going to see the logs of that build process. Right? When you move into a corporate environment or enterprise environment, you're not going to be building on your laptop, right? So you're going to have these things called build pipelines, continuous integration, continuous delivery. We're starting to see the start of that here, right? All these steps. I'm just seeing the logs from Google building this Docker image on my behalf. Right? It's still going through all exactly the same steps. Once it's finished, look, it's tagging it. Now it's pushing it to that container registry that we created before. That's pretty cool. So Tim's got a question. The image of the snapshot is all userland programs required. I'll come back to your question, Tim. It'll take me a little sec to read that one. Okay, so we have an image. It's in a central location. We know that it works. Let's get to Kubernetes. We have all the building blocks. We have a container. We have a central location. My image. Here's my image. That is not the image name again. Let me copy out my image name into a different screen. I'm going to put it into my to-do because I need to use this a couple of times. Okay, there's my image. What I'm saying here is, I'll remove myself so you can actually see the command. kubectl. Okay, this is interesting, right? I'm going to let you in a little secret. Kubernetes is open source, right? It can run on any provider. It can run on your laptop. It doesn't matter. Okay. kubectl is the open source command that we use to actually engage with Kubernetes, I need to have the Kubernetes cluster first. So I need to create a cluster. Where should we create a cluster? Who wants to put it in Melbourne? I would like to put a Kubernetes cluster in Melbourne. Guess what? You're a couple of months too early. Melbourne is getting a region, but it is not ready yet. So I am forced to put it into Sydney. I just ran a command that I have not enabled at the API for Kubernetes. Kubernetes API needs to be turned on. So we go to API and go to the API dashboard. And we're going to search for Kubernetes. Here we go, Kubernetes engine. Please do not confuse the two. Kubernetes is open source. Kubernetes engine is Google's managed service where they've taken open source. They then provision on our behalf. They do all the centralized logging. They do all the monitoring, and they provide a nice, simple API interface and a web interface for us to engage with Kubernetes. Okay, that's called Kubernetes engine, or GKE. Okay, so it is Kubernetes, but what you're seeing now is Google slant on Kubernetes. In fact, if this is your first entry to Kubernetes, you're probably being spoiled. All right, so Google is made things so simple. You're going to see we're going to create a cluster, and it's going to be one command line. Sure, you would do a little bit more effort in architecting and things like that when it comes to deploying this at an enterprise level, but for development, we're going to be good. Let's do a refresh on this screen. Here we go, Tim. I'm using a Linux VM in the cloud. That is correct. That Linux VM is called the Cloud Shell. Google provides that to you for free. Kubernetes engine, does anyone have any idea on where or what facility do our containers run on inside Kubernetes? Is it running on physical tin? Is it running in virtual machines? What do you think when it comes to cloud? What's the most likely destination? Does anyone know? Got a couple of choices here. So Optimus has come in and said virtual machines. Chris is saying virtual machines in a data center. Yeah, absolutely. Right. So when it comes to running, at least in Google Cloud, and I think it's fairly confident to say the same for the other large providers like AWS and Azure, virtual machines are so configurable, right? So they abstract away the hardware. So when you're creating Kubernetes, all the worker nodes, right? Bit of a secret. We call them nodes. We don't call them virtual machines, but all the worker nodes, which are running your Kubernetes containers or your Docker containers, they're just virtual machines, right? So when we finish creating this cluster, we are creating a cluster right at this moment. I use this single command. I said, create a container cluster, and I called it the barbecue cluster. Oh, no, I did not. I missed the C. I called it the barbecue luster. There you go. So you'll be able to see how real time this is. And I'm storing that in Sydney. So this will take a couple of minutes to start up. So let's have a look at what's happening. There are virtual machines being provisioned in the background. I should be able to see that. You don't need to do anything. They're all being created on our behalf. Here we go. This is a service called Compute Engine. This is Google's virtual machines. I've now got 3 virtual machines, and this is where my containers are going to run. They're all being configured to be treated as almost like a single unit. You know, they make up what we call the worker nodes, right? Containers are going to be executed on these virtual machines. Who is managing all of this? Like, where's I don't see the orchestrator. I don't see this master. I don't see the control plane. If you were to build Kubernetes open source yourself, it has worker nodes and it has a control plane. In Google Cloud, Google has decided to make your life so much simpler. They fully manage the master control plane. We don't even see it, right? So we have the option to configure the master. So if we come down here to Kubernetes engine and I go into clusters, now we see that we have a cluster that's being created at the moment, right? But the actual setting up of the databases, all the agents to manage all the nodes, the interactions between Kubernetes and the underlying platform, these are all capabilities built into the control plane, including things like the actual API that we talk to, the built-in scheduler, right? That's all part of the master. And again, Google's just doing that for us. Let me do a refresh on this one. So Chris has a question. So it's doing load balancing automatically? Yeah, yep. So we've got 11 minutes. I am going to try and attempt to deploy our Snags Sanger API to behind a load balancer. And we're going to have multiple containers. We're going to see it automatically scale up and scale down. So yes, here we go. Our cluster is now ready. Yes, it is called the barbecued luster instead of cluster, but it exists. If we go in and have a look, we have, going down towards the bottom, our default pool. This is our nodes. Remember, we don't call them virtual machines, but we call them nodes. And if I go down here a little bit further, 1, 2, 3 virtual machines. They've all got a certain amount of CPU. They've all got a certain amount of RAM. We now have worker nodes. We now have our control plane. Collectively, that's known as a Kubernetes cluster. Okay, one command, we're up and running. So how do we use this Kubernetes cluster? We've already got our image. We use the open source command, kube control. Sometimes you'll hear that referred to as kubectl. So particularly in the US, I see quite a few of my colleagues are using that over there. And I'm going to say, let's create something called a deployment. A deployment is just it's a wrapper around our deployable unit, which contains our container. And in the deployment, we can tell it things like here, create a deployment with this particular image. Control C, Control V. Okay, says it's done. What does that actually mean? What did we just do? This command line tool talks to the master. The master has an API. So it's talking to the API. Yep, okay, I'm with you. The master then talks to each of the different nodes. We had those 3 virtual machines. Those 3 virtual machines all had an agent on there. That agent's called a kubelet. So K-U-B, I'll spell it out here. Kubelet, K-U-B-E-L-T, E-L-E-T. That is what the master talks to. So the master can tell what nodes are available, how many containers are already deployed. And so we've just said, please, master, could you please create a deployment for me? I'm going to call my deployment Hello World deployment, and I'm going to use my image that we created earlier. How do we know it worked? When we deploy an image into Kubernetes, we don't actually deploy a container. We deploy what's called a pod, and a container goes into a pod. So a pod has some different attributes, like it has an IP address. And I can see if I just go kubectl get pods, I have a deployment and it says it's ready. It was created 83 seconds ago. Okay, so I have a deployment, which is a pod. That pod contains my container. I built that container from this image. Kubernetes is a very big stack, okay? I'm giving you a very gentle introduction here to this one. At an enterprise level, there are quite often IT organization teams which manage the Kubernetes clusters. So don't feel if you're getting lost, don't feel too bad. So we have our deployment. Let's go have a look visually. I go to workloads inside Kubernetes. and we have our Hello World deployment. If I click on this one and we scroll down, we have one managed pod. So I mentioned that we don't deploy containers, we actually deploy pods, but inside my pod, if I have a look inside here, I can see it is running. Here's my container. So we've successfully taken our API from running on my laptop. We've put in a central registry. We've now made that available to a Kubernetes cluster, which we just built, and that's now running. So let's see if we can access it. Oh, we can't. We can't access it because we haven't exposed those ports. Remember, my container, I built that listening on port 8080. If I go back to my code and we go back up to my index.js, it was listening on port 8080. I haven't told Kubernetes engine how to accept requests, how to forward those requests into my container. Let's go back and run one more command. And coming back to Chris asked a question. So is it doing load balancing automatically? You're about to see this. And I would say it doesn't get much more automatic than this particular command. All right, so we're going to do kubectl. We're going to expose our deployment. And we called this deployment Hello World deployment. Now I'm going to call what we're creating right now, it's called a service. All right, so service gets exposed by a load balancer. So I'm going to say, let's call my service the Hello World service. And we're going to make it a type of load balancer. So why is this important? Well, notice I'm using an open source command, kubectl. Nothing I am typing here is specific to Google Cloud. This command, I'll execute it now. I'll explain to you what's happening. We're now going to expose our deployment, this particular deployment. We're going to expose that with a service called Hello World service. We're going to do that by creating a load balancer. We're going to say, if a request comes in on port 80, translate that to 8080 because that's what I was listening to inside my container. Does anyone know what load balancer it could be using on Google Cloud? Let me rephrase the question. Do you care? This is open source. I could run this same command on AWS. It's also going to provide a load balancer. I don't care. Kubernetes is abstracting away the cloud vendors. Right? If you have skills in Kubernetes, you're able to deploy across multiple cloud providers. And you don't need to know the back-end systems. You don't need to be trained as much. I still would argue you need to know to understand some of the back-end, but I don't need to know that on Google, this is deploying a network load balancer. Okay, that's a regional load balancer. It can load balance TCP and UDP, and I can specify multiple ports. Yep, that's all good. I just want a load balancer. So I just put type load balancer. If I did this command on AWS, it's going to deploy something called an elastic load balancer. Yeah. Let's go have a look at our app. Actually, we're devs. We need to do this on the command line. Kubectl get services. Whoops, helps if I can spell. Get services. We have a load balancer. Here is my external IP address. Let me see what happens if I pop this external IP address into my web browser. Here's my Snagsanger API. Okay, we are now running in a Kubernetes cluster. That seemed like a lot of work. We had to create these three worker nodes. We had to have this master. We had to create these things called deployment. Deployment sent these pods. Containers go into pods. Like, we were doing this 30 minutes ago. So what's the advantage? The advantage is things like this. If I go back to the command line now, and I say, oh, my Snagsanger API, it's really popular, right? I need to spin up some more instances. kubectl scale. I want to scale my deployment called Hello World deployment. I want it to scale up to 10 instances. Let's have a look at this one. So now if I go kubectl get pods. Oh, look what's happening in the background. Now I've got 10 pods. 2 of them are running. 8 of them are being created. This is only 6 seconds ago. Let me run that command again. I now have 10 containers, 10 pods running. One of them's been there for 7 minutes because that's when we started up. Okay. I'm starting to see the value of Kubernetes here now, right? That was pretty simple to scale out. We can just as easily scale back in. So if we go get pods again, I should now be down to 3. Look, my containers are all getting terminated. 3 of them will remain. So if I go get pods again, there's 3 left. I didn't have to know, is that virtual machine overloaded? You know, the master, the Kubernetes master knows where to send all the requests. It knows where to start up those containers. At no stage, but my API is still okay because it's hitting the load balancer. Every time those containers spin up, if I go back here and I spin up back to 10 again, there are 10 containers starting. Those 10 containers not only start, Kubernetes checks it to actually make sure, hang on, are you actually running? Are you healthy? If you're healthy, it then adds it into the load balancer. Once it's added into the load balancer, then these connections that I'm hitting here, I can hit refresh all day. I'm never going to get an outage in this particular circumstance. So question, Chris has one, is it still running on 3 VMs? Yeah, good question. Yes, it is. So I now have 10 containers spread across 3 virtual machines. So yes, that is a good question. I didn't have to think about it though. Kubernetes did that for me. Mickey has a question. Multiple pods can run on one virtual machine, I believe. Yes, I believe the number of virtual machines used will depend on how much processing power needed by each node. You are spot on, my friend. So the virtual machines, you can have auto-scaling nodes. So if Kubernetes decides we've run out of capacity, it'll spin up a 4th virtual machine and a 5th virtual machine, right? All that resource management is provided to me by Kubernetes. Right? Hopefully you're starting to see some of the reasons why we tackle or at least approach Kubernetes. Right? Some of the big ones, open source, right? So you're not getting locked into a particular cloud provider. That's important for many customers, right? Particularly those that are in a multi-cloud environment, right? If you look at the large financial institutions, they are governed by organizations in Australia like APRA. They kind of have rules that says, you know what, don't put all your eggs in one basket because if you're not able to take transactions and all your ATMs go down, then yeah, that's not so good, right? So being able to have a technology like Kubernetes, which can run across multiple cloud providers and provide you that simple, abstraction, that's valuable. What other questions do we have? Did I specify the 3 VMs? No, I did not. So you absolutely can specify the 3 VMs. In this case, I took the defaults and Google decided the size of those virtual machines and how many to create. So at an enterprise layer, you would absolutely control that yourself. How are we traveling? We are 2 minutes past 5. I'm going to demo one last thing because we are developers. Where is my Snag Singer API version 2? Right? This is where the value comes in. So we are going to, let me find my build command from earlier. Here we go. We're going to run gcloud build. I'm not going to build it on my laptop. We're going to submit it. We're going to tag it. We're going to call it. Where is my image? My image name was, here we go. We're going to call this, now version 2. It's getting built. It's being built by Google. It's going to get stored in the repository. Okay. Here we go. It's nice and quick. The build service has a lot more CPU than what I do on my development machine. Here you go. It's going through the build right now. It's almost finished the build process. It's now getting pushed up to the central repository. I pushed it with a version 2 tag. So it's the same image, only I've said it's now version 2. So once it's there, 3, 2, 1. Come on, nearly. Here we go. Our image is in the central repository. Let's tell Kubernetes to now update. So we're going to say set the image, and I'm probably in the way, so let me just move myself. Okay, set the image. We're going to say on the deployment. Remember we had a deployment called Hello World Deployment. And we're going to say the API demo image now is that version 2. That's it. I can go to lunch now, right? Because if I go back to Kubernetes and let's have a look, we have our workloads. Oh, there's something going on. Let's see what's going on in our deployment. Oh, we got revision 1 is getting terminated. We've got all these revisions 2s. In fact, if I do a refresh, I was too slow because we missed all the action there. Look, they're already updated to version 2. If I hit refresh on my Snagsang API, we are now version 2. We are done. That is the value of Kubernetes. Questions? Imagine, yes, that was fast, Optimus. Imagine doing that against thousands of containers, right? Most organizations now are aspiring to take a microservices approach. Containers are a preferred deployment unit for microservices. So one application, that could be 10 different microservices, 10 different containers. And if you want them all to be able to scale independently, every single microservice, you're in the order of hundreds of containers very, very quickly. A single command like that it's a godsend. It's fantastic. You know what? It's a single command to roll back to the previous version as well. Let's have a look. Other questions? Mickey, if you wanted to run version 1 and version 2 at the same time, can Kube do that? Oh, yes, you can. So you're referring there to A/B deployments. Yes, it can even do what we call canary deployments. So canary deployments is where we work with the service, work with the load balancer. And we can actually specify a certain percentage of connections to go to my version 2. So maybe 5% of my customer base to go to my new version and 95% still go to version 1. So that's a canary release. We can do blue-green deployments, right? So let's have, which is what you just saw then, by the way, in the demo, that's called a rolling update. We gradually rolled through every container. We ensured that we kept the minimum available. I think we said we had to have 10 up and running. There was always 10 up and running. Kubernetes ensured that, right? So it created a version 2, just made sure it's healthy, removed to version 1. Created another version 2, removed to version 1. It rolled through into those updates. So very good for deployable, for deployments. Next question, Joseph. Can Docker containers talk to each other? Yes, very much so. And that is the microservices world, right? So that example I gave earlier where one single application may be actually 10 different containers, they absolutely need to talk to each other. And being software engineers, hopefully you've had some exposure to being able to build microservices in a distributed fashion, knowing that it's going to be deployed on services like this. So it's extremely important. I've had CEOs or CIOs tell their IT teams, we're moving to containers. That's not going to work if the devs didn't architect for microservices and containers in the first place. And so you need to start with the devs. Thomas, well, that's really cool. Yes, that's a lot of people have that exact same feeling. So thanks, Thomas. Navya, in each pod, a new image of the container, which has been made as a service. Yes, so that new image gets put into a brand new container. The old container gets removed and a brand new pod gets deployed. That new pod, when it gets deployed, it then has to get added into that load balancer. But it only gets added into the load balancer once the health check, once we actually know that it is up and running successfully. So yes, so there's a lot of checks and balances in place. Because what if I had, maybe I had an error, a syntax error in my code and my app didn't start. Kubernetes won't actually provision it and allow it to accept requests. So it's very cool. If you're running, Chris has a question, if you're running one pod and 3 virtual machines are too redundant? I wouldn't say they're redundant. They're there for high availability. So what if that first virtual machine goes down? Then we have the others that are there available for us. So, but yes, they are somewhat redundant in the sense of the way you're asking that question. Let's have a look. Keep the questions coming. Yep, absolutely. Do you get charged per instance or per virtual machine? Great question. Okay, so in that case, we did not increase the number of virtual machines, right? So the virtual machines was always 3 in that demo. I went from 3 containers to 10 containers. So when you move to a cloud world, you'll very quickly come to an appreciation that there's lots of little resources you can use. So things like the virtual machines, that didn't change. So you're not going to have an increased cost for virtual machines. However, the fact that I've got more containers, they're probably going to use more network requests and send more network traffic. So I'm probably going to have an increased cost for my network fees, but I'm probably okay with that because I scaled up to 10 containers because that means my app is becoming more popular. So hopefully I'm charging my customers. So yeah, it swings and roundabouts there. Kubernetes cost, no, there was no extra cost. Networking cost, yes, potentially there was an increase. How does Kubernetes know if it's safe to terminate a container? What if it's in the middle of service request? Yes, great question. I love it. So we're able to monitor those connections from the load balancer to the container. So, and we do something called connection draining, right? So it's able to see that if there is a container that does not have any connections, it will terminate it. If it does have a connection to a container, it will not send new connections, right? It starts the draining process. It waits for that connection to actually be removed automatically or just through normal use. Once it gets removed, then it'll get replaced. There is a timeout you can set though. Maybe you're only going to wait for 60 seconds. And if that connection's still there, then you can pull the pin. But great question. Okay, hang on, I lost track. Yes, Irfan, what do we got? Irfan's got here. So a container is like a server that can serve our users. That's one way to think of it, yes. Yes, so it is certainly serving my API. I have 10 versions of that API at the moment that are being represented as a single unit because I have a load balancer sitting in front of them. So that's correct. Meeting was started before 1.5 hour minutes. How many minutes? I'm late joining it. Oh, Pallavi, you feel free to ask questions, but we're actually close to the end of this one. Donna's already answered that. Fantastic. David, can Kubernetes only scale a specific image and leave others alone, like a single container for a shared database, but still have multiple Node.js container instances? Yes, it can. So I have glossed over a lot of the advanced configurations in Kubernetes, right? In fact, you have only just touched the surface of Kubernetes. You can define deployments, right? And those deployments are how you wrap metadata around individual pods and containers and how many there should be, how many there shouldn't be. So we were just working with a single deployment in that example. So to answer your question, David, absolutely, you certainly can configure that. Navya, is Kubernetes tough to manage if I don't use any of the cloud providers like GCP? Okay, without even reading the rest of your question, I'm going to say yes. Okay, I think, let's forget this is a Google Cloud user group. If you came to me and said, Dan, I'm thinking about building a Kubernetes cluster, should I roll my own or use a cloud provider? The answer will always be use a cloud provider. Okay. Kubernetes is tough, right? Particularly if you're installing on bare metal. Great for a learning experience though, right? So if you want to learn how it all works, that's fantastic. But if you're looking to use it for your startup, for instance, no, I would prefer you go to Azure or AWS if you didn't want to go to Google, rather than roll your own. So I did some training for a company that it took them 12 months to get a cluster production ready because they had to go through dev and test and everything to make sure it was all fine. And when they came to my class, they told me their story that, yep, we're Kubernetes experts. We've been doing it for 12 months. I said, oh, how'd you go with the centralized logging? How did you get logging from your nodes and from your containers and from your load balancers and firewalls and all that into a central location? Because remember, your containers may only be there for 30 seconds. How were you able to get all your logs out into a central location? Oh, we haven't tackled that yet. We haven't even started. I'm like, oh, you're 12 months in? Yep. We have centralized logging. That demo, I could take you in the back end and very quickly we can see if we go down to, actually, I'll show you in this view. If we choose a little bit higher, here we go, logs. Let's have a look at my container logs. I'm now going to have, if we go down a little bit further, run a query on my container logs. We can see all the logs coming in from my container. And we can drill in and see that service starting. So remember I had the server is ready. We will see those console logs showing up inside cloud logging. So, next questions. Okay, I'm scrolling off the page. Let me just catch back up. Okay, Kubernetes stuff. Yep. Stavia, thank you very much. Very, very kind. Okay, if we run multiple services, say a web app and an API, would that normally be in the same cluster? I would. Okay, so personally, the way that I recommend customers and the way that I use Kubernetes is I have separate clusters based on the environment. So I would have a production environment and a dev environment. That way I can have different versions of Kubernetes running in different clusters and test them before I roll them into production. So if I have a production cluster, I think we can have, let me have a look, maximum pods GKE. In a single cluster, we can have, here we go, 150,000 pods, 3,000 containers running inside your Kubernetes. So I think you'll be able to fit them into that one production cluster. You should be good. Okay, Andrew's asking, what if you wanted Kubernetes to load balance across multiple cloud services, that is GCP and AWS? Would that be possible? If so, where would the central management, please? Okay, I'm not going to be able to answer this one quickly. However, I'm going to try and find the diagram here. I haven't vetted these diagrams, so I'm just very quickly looking. Google has a service. The service is called Anthos, right? So think about Google Kubernetes Engine running in Google Cloud, right? We have that now. But think of Google Kubernetes Engine also running in AWS. That is a thing. That is real. We have that right now. I think about Google Kubernetes Engine running on-premise in someone's data center. That is real right now. Imagine a monitoring platform, a centralized logging platform that looks at all three of those deployments, AWS, on-premise, and Google Cloud, provides you a single dashboard, alerting and monitoring. Yeah, welcome to the world of Anthos. All right, so to answer your question, yes, you can certainly do that. Chris is asking, is there something similar to Docker Compose for separate services? Yes. So you would, in the deployment, so in the deployment that we created today, I just did that on the command line, and that's for introducing Kubernetes, that's sufficient. When you start to use Kubernetes in anger, you'll be defining everything in YAML files. So that deployment can have multiple images and multiple containers specified, multiple ports being exposed, and it behaves very similar to what you're suggesting with Docker Compose. Navya, yes, oh yes. It is a big stack, that's for sure. Mickey's got a question. Would you have your database in a container or would you use a cloud database? Okay. My personal preference, I do not run my databases in containers. Okay, it is possible, so don't get me wrong. You are able to have long-lived containers and you can have persistence around the storage and things like that. My preference though is to use a cloud database. If it's relational, you'll be using something like Cloud SQL. If it's a NoSQL database, you can't tear me away from Firestore. Right? I love Firestore. The only thing I would like Firestore to be is open source. That's my only thing that I miss. If you're after open source, then MongoDB. that would be my preference. And if you're looking for a managed service for MongoDB, that would be MongoDB Atlas. So I set that up for a lot of customers. So have your containers talk to that. Let's have a look. I have various Docker batch jobs being pushed to a cluster, and batch jobs have certain memory and CPU requirements. Docker Kubernetes having a queuing mechanism. Yes, absolutely. So the person asking about the Docker batch jobs, we can absolutely do that. So that's a special type of deployment. And I run a 3-day class where we teach people how to use Google Kubernetes Engine. And that is actually one of the labs that we go through. So pulling off a queue to do those Docker batch jobs. Firestore is good. Yes. Now you're talking, Mickey. Thumbs up there. And last question I can see, where can I learn more about cloud computing, and is there any cloud computing certifications worthy of doing? Rightio. You were setting me up for that one, weren't you? So my job, what I do for a living is I'm a Google Cloud trainer. So I spend my life training, particularly on certifications. Let me open up a new window. I'll quickly get you to the information you want. Let me pick any of these. Let's have a look. Prepping for professional cloud architect. Day 1. Okay, so this is where I spend most of my time, is prepping people for industry certifications specific to Google. Google does have multiple, so Google Cloud certifications. They do have different tracks, learning tracks, depending on what you want to pursue. So you'll see here there are, make that resolution. Here you go. These are all the industry certifications. These are highly desirable. Okay. So when I say that, is they are not only highly desirable by customers, but partners, Google Cloud partners. If that is your aspiration, do have to have a minimum number of certified professionals on their staff. So yeah, in most cases, like when I'm training large banks in Australia and we're training up hundreds of their operational staff, they are all aspiring to get certifications like the professional cloud architect or the professional cloud engineer. They're infrastructure orientated. Cloud developer, I do not have enough people doing that class. I actually enjoy this class. Teaching developers how to build their applications, how to architect their applications, knowing they're going to deploy it on cloud. Thomas is asking, do certifications expire? Yes, they do. 2 years. So every 2 years, you need to recertify. Okay. So this one, where is it? Data engineer certification. If you are data orientated, then creating data pipelines are highly desirable. There's not enough people in the industry at the moment that have those type of skills. Good questions. I like it.
Do we have any other questions while we've got Dan here?
Let me stop sharing my screen.
Well, if you are able to turn on your mic briefly, it would be really nice to switch on your mic and give Dan a round of applause.
Great, thank you, everyone. So that was a whirlwind tour. So hopefully you got something out of it, and at least have some idea now of where to do for further exploration. So that's good. Thank you.
Wow, I learned so much. I'm gonna go over and try and deploy my own cluster now. It's gonna be great.
Yeah, you should.
Yeah.
Mm-hmm.
Oh yeah, I'm just excited. I'm like, nah. Like, I've already got an idea of what I'm going to deploy. This is going to be great.
Yeah, it's Kubernetes is. Let me just see how many people we've got left on the call. Okay, so we've still got quite a few. Kubernetes is one of these things. Enterprise focus, absolutely. If you're a startup, I actually prefer services like Cloud Run. which abstract away Kubernetes.
Mm.
So we still need to build our container. Yeah, still need to build our container. And as a dev, I could deploy that API right now, and I don't even need a Kubernetes cluster because Google abstracts that away. So if you ever want to see that type of technology, invite me back because yeah, I can't stop talking about that one. That is fantastic. That's more the serverless world, right? It's where you don't need to know about the underlying infrastructure. And the other nice thing about Cloud Run is it is also based on an open source standard. So Red Hat has implemented it, IBM has implemented it, Azure has it. So yeah, it's very good.
Amazing. We've got a yes please in the chat, so
Yeah.
we'll have to set that up.
Auto scaling. Yep.
Awesome. Yeah, and for people who are watching as well, if you'd like to see more events in the future, make sure to follow both the UNSW and UniMelb clubs on Facebook. And Zachariah, I'm sure you've got other places to promote as well.
Yeah, definitely. We have Facebook, Discord, and I think the recording will be posted to the YouTube. I provided a link before where we have all those links. I'll just share it again, and that's pretty much it.
Awesome. Well, thanks everyone for your time tonight. I hope you have a fantastic weekend ahead. So that's a wrap.